short story, Isaac Asimov envisioned a world powered by solar power harvested in space. That science fiction dream came a little closer to reality earlier this year.
What if the future of electricity isn't on Earth at all? While most solar farms wait for sunrise, Japan is testing a way to harvest constant sunlight in orbit, convert it into microwaves, and send it back down, turning space itself into the first layer of a new power system. The day solar power escapes the sky. That is the bold idea Japan has been working on. Instead of placing solar panels on land, Japan wants to place them in orbit, where sunlight is stronger and always available. Then, that energy could be sent back to Earth without wires. It sounds like science fiction at first, but the idea is real, and Japan has been studying it for years. The goal is not just to make another solar farm. The goal is to build a new kind of power system, one that starts above the planet. This is what makes the story so exciting. Japan is not only trying to improve solar power, it is trying to change where solar power begins. Why Earth-based solar still has limits. Solar power on Earth is useful, but it has a basic problem. It is never fully in control. At night, it stops. In bad weather, it weakens. In winter, days become shorter. In crowded countries, land is limited. So even though solar energy is clean and promising, it is still interrupted again and again by the conditions around it. That is why Japan is looking upward. In space, sunlight is stronger than it is on Earth, and it is not blocked by clouds, storms, or the normal cycle of day and night. For a country like Japan, where land is limited and energy security matters a lot, this makes the idea especially important. So this project is not about doing something futuristic just for attention. It is about solving the basic weakness of normal solar power. Down here, sunlight comes and goes. The idea Japan never gave up on. This idea is not new. In fact, it has been around for decades. The first major concept for collecting solar energy in space and sending it to Earth was proposed in 1968 by engineer Peter Glaser. At the time, it sounded far too advanced, too expensive, and too difficult to build. So for many people, it remained only a dream of the future. But Japan did not leave it behind. Research in Japan began in the 1980s, and by the 1990s, the country was already studying a model called SPS 2000. That was important because it moved the idea from imagination into real engineering. People were no longer just asking, wouldn't this be amazing? They were asking, how could this actually work? That long-term commitment is one reason this story matters today. Japan is not suddenly chasing a random space idea. It has been patiently working on this vision for years. How Japan wants to send power back to Earth. The most important part of this system is not just collecting sunlight. It is sending the energy home. The basic process works like this. A satellite in space collects solar energy using large panels. That energy is turned into electricity. Then the electricity is changed into a form that can travel through space and the atmosphere, usually microwaves, or in some concepts, lasers. Once the energy reaches Earth, it is received on the ground and converted back into usable electricity. This is what makes the system so different from an ordinary solar farm. A solar farm produces power exactly where it sits. But in this system, energy is collected in one place and used in another. Power is no longer tied to the land where it is produced. That is why wireless transmission is so important. If Japan cannot send the energy safely and efficiently, the whole idea falls apart. The real challenge is hitting the target. Getting solar hardware into space is hard, but one of the hardest parts comes after that. Once energy is turned into a microwave beam, it has to be sent from space to the right place on Earth with extreme accuracy. Even a very small mistake can push the beam off target. Over such a long distance, a tiny error becomes a serious problem. That is why beam control is one of the most difficult parts of the entire project. Japan's research shows that the system needs incredibly precise aiming. It is not enough to generate power in orbit. The energy must arrive at the exact receiving station below. This changes the whole picture. The project is not only about solar panels in space. It is also about guiding invisible energy across the sky with near-perfect control. And that is what makes this idea so difficult and so impressive. From research to a real test in orbit. For a long time, space solar power was mostly an idea on paper. Scientists studied it, tested parts of it in labs, and built small experiments on the ground. But now, Japan is moving towards something more real. One important step is the Ohasama project. This is not a giant power station in space. It is a small demonstration mission designed to test whether the basic system can work in orbit. The goal is to collect energy, convert it, send it down as microwaves, and see if it can be received properly on Earth. That is why this stage matters so much. The project is not trying to power cities yet. It is trying to prove that the chain itself is possible. If that small test works, it gives Japan something much more valuable than hype. It gives real evidence. The scientists building the invisible link. Big technologies do not appear all at once. They are built piece by piece by researchers who spend years solving very specific problems. In Japan's case, Kyoto University has played a major role, especially in wireless power transmission. Professor Naoki Shinohara is one of the important figures in this field. His work has focused on microwave-based energy systems and the technology needed to move power through the air without wires. This part of the story matters because space solar power is not only about collecting sunlight. It also depends on the people designing the transmitters, receivers, and control systems that make the whole process possible. Without that research, the satellite would be useless. So behind the idea of power coming down from space, there is another story. The quiet work of engineers and scientists teaching electricity how to travel in a completely new way. Why the world is watching this. If Japan can make this work, even on a small level, the meaning goes far beyond one country. A system like this could change how renewable energy works in the future. Instead of depending fully on weather and local conditions, power could become more steady and more flexible. JAXA also says this kind of system could send electricity to different places when needed, which makes it feel less like a normal power plant and more like a moving energy network. There's also another possible advantage: resilience. Because the power would come from space, the system may be less dependent on long ground-based infrastructure that can be damaged by earthquakes, storms, or other disasters. That does not mean the whole world will suddenly switch to orbital solar energy. But if Japan proves the concept, it could open the door to a very different energy future. The planetary grid is still far away. This is where the dream meets reality. A full space-based solar power system would need huge structures in orbit, cheaper space transport, reliable assembly in space, long-term maintenance, and very efficient power transmission from start to finish. Every part of that process is difficult, and all of it has to work together. JAXA makes it clear that a large commercial system is still far away. It is not something that will arrive in the next year or two. In fact, it could take several decades before a truly large version becomes possible. So yes, the idea is exciting, but it is also one of the hardest energy systems humans have ever seriously tried to build. That is why progress may be slow. Not because the idea is weak, but because the challenge is enormous. So, what is Japan really launching? The honest answer is this: Japan is not launching a finished space solar grid that can power the planet today. What Japan is really moving toward is a practical test of the core idea. It wants to show that solar energy can be collected in orbit, changed into a wireless beam, sent to Earth, and received successfully on the ground. That may sound smaller than the headline, but it is actually the most important step. Because if this first chain works, then the idea stops being just a dream. It becomes a real technology path. So the biggest truth in this story is simple. Japan is not launching the final system yet. It is launching the beginning of one. And sometimes that is how history starts. Not with the finished machine, but with the first working proof that the impossible may be possible after all. If you enjoyed this video, like, share, and subscribe, because the next big energy breakthrough may already be rising above the Earth.